Greetings everyone. I, Jayanandani Singh, your anchor, along with my co-anchor, Ms. Priyanka Shukla, would like to welcome you all to this distinctive session. This exceptional session brings inspiring academic journey, deep ideas, and meaningful conversation. Today's session is special because we have with us a visionary scholar whose work has shaped theoretical computer science and influenced generation of students. So before we start with this interesting talk, I would like to share few lines about our special guest, Professor Nitin Saxena. He is an outstanding figure in theoretical computer science, mathematics, and national technology leadership. Sir is currently a professor of computer science and engineering at IIT Kanpur, the N. Rama Rao Chair Professor and the Founding Dean of the Vadvani School of AI and Intelligent System, where he is leading one of the India's most ambitious academic industry AI initiatives. An alumnus of IIT Kanpur, Professor Saxena completed both his BTech and PhD here and earned top honors including the Best BTech Project Award and the IBM Outstanding PhD Student Award. He is internationally renowned for his groundbreaking contribution to the AKS Primality Test, famously known as the Primes Isn't P, which earned him two of the highest honors in theoretical computer science and mathematics. Sir is a recipient of the India's most prestigious scientific honors, including the Shanti Swarup Bhatnagar Prize and J.C. Bose Fellowship. He has also supervised dozens of PhD scholars. He is a visionary researcher, institution builder, and a global ambassador of the Indian science. Please join me in welcoming Professor Nitin Saxena, sir. So it is an honor to welcome you.
Thank you.
So let me begin this conversation by going back to the very start of your journey. So what initially sparked your interest towards the mathematics and theoretical computer science?
Yeah, before I answer that, I want to thank you both and the students and obviously my organizers. They had asked me to give a talk, but I felt that since there are young minds and of a diverse kind and interests, so it will be better if we can collect their questions and then I can answer them. So this is why I agreed to be subjected to this interrogation. So I hope you enjoy it, and then in the end you can also ask questions after I have answered. You may have new questions. Yeah. So the first question is that how did my interest arise in theoretical computer science? So during school days, I got interested in math. So the kind of math that is taught in good schools and which is there in good school books. So I was interested in math, and especially in math, I was interested in number theory and algebra. So that is what I really wanted to do. But then it looks, when you are a school kid, it's very hard to actually go for pure math because it always seems that everything is already solved. And then if everything is solved, then what will you do and where will you get a job? Because in India, jobs are very important. If you don't have a job, then nobody will give you any money to eat food and to live in this winter, right? So for those reasons, there are other pressures. So I went for engineering, then I went for computer science, and then in computer science, I found theoretical computer science, which is similar to my interests. So that was something I wanted to do already from school, although it was not clear that it will be theoretical computer science, but it was to be whatever I would do will be highly mathematical.
Okay, right, sir. So, sir, during your student year at IIT Kanpur, what made you choose the theoretical path instead of a more industry-driven or programming-focused direction?
Yeah, so industry, I never liked industry too much because industry is all about what can they do today, and it is mostly about in India services or development of products. So I was not very interested in practical things because the kind of math I am interested in, it doesn't apply immediately to practical things. At least this is what one would seem to think if you look at the kind of math I do. So, and also I did not have much patience in working with people who are practical. So I wanted to talk to people who are more theoretical. So which is why industry was, I never wanted a job in the industry.
Okay, that's please over to you, ma'am.
So that gives us wonderful insight into your early journey, sir. Moving ahead, let us talk about your research journey and thought process. How do you personally connect mathematics with computer science in your research approach?
In my research approach, computer science with math. So no, so the kind of computer science I do, it's already math. I don't have to connect anything. It's theoretical computer science, and even the algorithms you study in your algorithm data structure courses, or the ones you will see in some of the research presentations in this conference in cryptology, it is already math. So this all in ML also, the algorithms you will see and the analysis you will see, it's all math, just slightly different areas of math. So math is obviously the core, but then there is the other side, is that what are you doing with that math? Is it solving some problem which somebody else is interested in? Is the algorithm fast so that it can work on, let's say, big data, or it can work fast and so on? Or there is a crypto system which you want to attack. So you are a hacker, so can you actually attack a system and find the password or find the secret information? So that is the practical motivation, but the tools are all mathematical.
Okay, that's great. Building on this thought, and we also see AI these days. So, in today's AI-dominated world, where do you see theoretical computer science standing in terms of relevance and long-term impact?
So theoretical computer science was actually very popular when I was doing PhD and before that, because it would be the natural way to analyze all the other things which were going on in computer science. Let's say since 1950s. So 1950s to 1990s, it was very popular. Every practical concept we modeled in theoretical computer science. But at some point, the problems became too hard, and when you look in theoretical computer science, those problems seem intractable. But then other people with other interests, they could still find engineering solutions which work in practice. So all these problems which, let's say, approximation algorithms and now what you call AI or ML, these machine learning algorithms or artificial intelligence algorithms, the problem they are solving, theoretically they are actually intractable problems. They cannot be solved. They should not be solved. But anyways, engineers are able to solve it, because what they do is that they solve it only for the input that you are interested in, and the input which you are not interested in, on which those problems are unsolvable. So, so yeah, theoretical computer science helps you give this way to discriminate. The thing I was talking to in the introduction, that when you have this outer vision, then you can understand that what is going on. But then you cannot remain in that viewpoint of theoretical computer science, because you also want to, you may want to solve practical problems through engineering, which is a different art. So AI is that art. So you identify problems and inputs. So what is the meaning of input? So meaning of input is that, let's say there is an image, and you just want to understand whether the image is of a man or of a woman. Now this theoretically is impossible to solve, because nobody knows in this room from the face, how do you judge whether a person is a man or a woman? So whatever criteria you will put, that the person has a long hair, then she is a woman, there will be a counter example. Some women with no hair, right? So, or some man with very long hair. So whatever condition you will put, there will be an opposite example. So theoretically, it's unsolvable. So what are these algorithms doing? So these algorithms are actually tricking you. These algorithms work on most of the usual images, and you think that it works. So it's an engineering solution. But if you give it a image of a cow, then it may say sometimes that it's a man, sometimes it's a woman. It will not know that it's a cow. Okay, so the assumption is that nobody will give the image of a cow. Everybody will give the image of a normal man or a normal woman, and then it will work. So This is the practical aspect.
Right. Okay. So, sir, you are widely admired not just as a researcher but as a mentor and teacher also. So, what qualities do you look for in the students who want to pursue their research?
No, so I actually, my colleagues in the department and other places also find it surprising that I don't judge this immediately. I am quite patient and I give it years. So the student actually himself or herself has to prove that what is the student's worth. It's not for me to judge immediately. As Indians, you are all used to screening tests. You do a screening test, you do JE, you do GATE, or you do the entrance exam of this college, and you try to pass or fail. Right? That is what all you know, and that is what you think is the most correct way of sorting people. Uh, so that is not very good for creativity. So if you want the society to be creative and if you want the society to innovate, this is the worst thing you can have. There cannot be a screening test. It has to be based on what the person is interested in and how hard the person is going to work, which may not be clear in the beginning. So generally with students, I mean, since you use the word mentor, so mentor is a very heavy word. Mentorship can last for 10 years or lifelong. So I take it like that. So people who I want to mentor, I give them few months or sometimes even an year, and then they tell me what do they want to work on, and then we discuss every week, and we try to converge to some kind of a stable situation where both of us can work together.
Right. So,
Or
it is all
if it
about-
doesn't work, then I fire them.
Yes.
So you have to understand that I don't keep people forever.
Okay.
They get fired also.
So
Because
they
I
have
have
to keep
limited
performing.
I have limited time and resources. So I cannot just keep on taking people.
Right. All right. So as we have seen that students generally study for exams, and for them every subject is like a liability because they have to pass the exam in some or the other way. But then, as you are in the mathematics area, so how do you motivate students to understand the subject not just for the exam but beyond that also?
So that is how that is the way I teach. I mean, even in big classes, I teach about the basic concepts, and I don't give them anything programmatically that step by step, this is what they have to remember. I don't do that. So I give them a general idea and then I give them some more details and then some more details over time. But most of the things they have to figure out on their own. Yeah, so it's that is how, I mean, so then in this, maybe 70-80% of the students will fall out because they will not give the time and the interest that it requires, and the 20% will get better through this process.
So generally, like one question arises because majority of the students who are in BTech, they're scared of mathematics, especially. So how can they remove that fear?
Are they actually scared of math? They
We have
shouldn't
seen
be,
majority times.
but then they
that-
shouldn't be in BTech. I thought students who are interested in math only they go, well, not interested, but let's say who are scoring well in math,
Yes, sir.
only they go for BTech. If they are not scoring well in math, then they will not be able to do BTech, or they will not take BTech. Well, in India, parents also
Right.
force the students, so
Yes,
that's a
sir.
different. So you are asking me if the parents have forced the student to do BTech, what is my advice?
Yes, sir.
Well, they should revolt.
Okay, right.
Young people should rebel. That is how countries are built.
All right. Okay, ma'am, over to you.
So, taking this discussion forward, your career spans multiple countries and institutions. You spent several years abroad in Amsterdam and Bonn. What motivated your decision to return to India?
So, yeah, this question I'm asked every time, and then I give a different answer, probably different time. Every time is a different answer. So this time the answer could be that there are many reasons. One is that I was born and brought up in Prayagraj, which was Allahabad in those days, and then from there I came to Kanpur, to IIT Kanpur, and then most of the time I studied there, except for these 1 year visits during when I was doing PhD. So I'm attached to this. I mean, not just attached. I'm familiar with this kind of society. So when I came back, I wanted to be in the Hindi belt. Uh, so there's a natural affinity, and in addition to that, it was easy for me to find students and create a group in IIT Kanpur. So professionally also, it went much bigger than what I was maintaining in Bonn. In Amsterdam, I was a postdoc, but in Bonn, I was a faculty. So the group I was maintaining there, it expanded many-fold in IIT Kanpur. So professionally also, it made sense. So there are many reasons. Uh, Primary reason is probably being Indian, but professionally also it makes sense.
That's absolutely correct, sir. From here, I would like to understand, especially when it comes to institutions specifically, how do you balance three demanding roles: research, teaching, administrations, as the founding dean of Vadwani School?
Yeah. So how I manage? Well, the short answer is that I manage it badly. But so as you grow older, you are forced to do more things, even things that you hate. So yeah, I will not say which of these things I hate in the list of three that you asked. That will be controversial. But yeah, so this happens gradually. So teaching and research is what brought me into this faculty position, and then teaching is something that comes naturally when you interact with students. Um, and the third part is the translation part or the administration part. These days in IIT Kanpur, we have started another term which is translation. So the director and the institute is very passionate about translational activities. So there is a fourth activity. So before administration, I should actually talk about translation. So this is research, teaching, translation, and administration. So translation, I started with that around 4 years ago because of some of my friends with whom I created a center where we develop these AI products, largely for the government agencies. Um yeah, so translation was something which I found meaningful. It is work which has some utility. Although it may not be heavy research or it is not really heavy technology development, but it is something that the Indian people or especially the governments need. So in that sense, it has some utility. So I started that. Then with that translation work, there naturally came administration. So this is a natural flow of the river. But how do I do it? Well, the answer is badly.
Right. Okay. So, what is the one common misconception about theoretical computer science that you wish more student understood correctly? What is the common misconception about theoretical computer science?
Uh, Misconception, I don't know. I mean, this the students who are misconceiving should tell me. So what is the misconception? I don't know. I mean, it might be the same as maths, as you already said that
Yes, sir.
math people think is very hard, or they are. You said they are afraid of it, right? I think I did not answer that question. You
Yes,
had
sir.
some question about math phobia.
Yes, sir.
Yeah. So this theoretical computer science also might be a phobia because it is related to math, because it is math. Um, so I don't think this is a misconception. I mean, if a student is afraid of it and doesn't want to do it, then there is very little we can do. It's a question of preference. Uh, but I guess you mean to say that you have some core courses here which a student is forced to do. So how do you manage those courses?
Yes, sir.
So if there is a course which the student is forced to do in the BTech program, which will appear in the transcript, so then it is up to the instructor to make the course interesting by adding um, components which these students would like, which usually is, I mean, if it is BTech in computer science, then there are, I mean, almost all these algorithms we are studying because they are used somewhere. So you show the use. So if you show the use, then maybe you cover half of these students who have phobia. But there still remains the other half who are not even interested in these applications. So ultimately, you will come to a point where there will be students who are not interested in anything. So I don't think you can do much with them.
Then they have to find their own way.
You can just make them jog in your stadium. So you ask them to just go and jog. for 2 hours, and after that they will be able to appreciate that it's easier to sit in the class and listen.
Yes, sir. Absolutely.
Some physical activity is required.
Yes, sir.
In India, we do a lot of intellectual activity, but physical activity is then needed. If intellect doesn't satisfy you, then do physical activity.
Okay. Sir, what was the toughest phase in your research journey and how did you overcome it? What was the toughest phase?
Toughest phase has been during the student days also. I mean, definitely school and undergrad, and then after that also as postgrad. The toughest phase is this uh, when you think that things are very difficult and you will not be able to do anything meaningful. So the self doubt or the loss of purpose or thinking that in the future you will not be a great accomplished person. So those feelings are the toughest, which happen usually early on, but also later in life when because I mean, if you are a researcher or let's say you are a professional mathematician or a theoretical computer scientist, or even these days if you are a technology developer, you have a startup. So in any of these situations, you are always solving a new problem. Now, but just by the nature of it, new problems will be difficult, and what you have learned in the old solutions will not work. So this situation appears again and again, and depending on your personality and the circumstances, you have to find a, let's say, you have to clear your thoughts
All right.
and find a solution.
So I would like to ask a question beyond this list. When you were a student, so was there any inspiration in your life, like the person who motivated you to move forward? Or is it that you on your own, you established this milestones in your life?
Uh, no, so in the school its stage itself, there were many idols who I admired and whose biographies I would read, and especially the technical work in math, in that case math, that they had done, I would be quite enamored by those incidents, by those anecdotes. So there are many people. I could not name all of them, but many people in ancient Indian history, in modern Indian math, in the Middle Ages of Europe when the Enlightenment was happening.
Yes.
So I was interested in science history across the world,
Okay.
and especially math history. So there are many personalities who I admired.
Okay. So, sir, as we can see, there are mostly undergraduate students sitting here. So, I would like to ask, according to you, what are the 3 essential skills every undergraduate should build for a successful career?
Uh, so one is that I mean the curriculum in all these BTech programs is just like in school. It is to teach them everything, like one bit of everything. In school they see the same, in BTech they see the same. So in that obviously they don't want to fail those courses, so they have to somehow be okay in learning one bit from every course, so which is basically the breadth. But at the same time they should, while they are doing it, there should be an year, let's say second, third, fourth year, when they should focus, when they should know that there is one area in which they want to go into depth. Now this area may not be math or theoretical computer science, or may not even be computer science. It may be also be outside of computer science. Let's say it is in becoming a IAS officer. So if they are interested in that, then they should actually be interested in doing what an IAS officer does, instead of just because again because the parents are saying, so they want to become a babu. I mean that is also a fine way to live, but not the best way to live. So that is not what I mean by depth. So if you want to become, let's say, an IAS officer, then you should know what the IAS officer is supposed to do by in spirit, right? I mean, everything that happens in government, every position, there is something in spirit which the person is supposed to do. They will not do it usually, but still you should understand what the spirit is for that position. So you should have depth in that. So there is this breadth, there is depth. You identify. You will not identify in first year, but Let's say as you are doing the breadth studies, you will focus on one thing, you will get interested. Or you were interested already before BTech in that, so you can come back to it. So that's the depth thing. And yeah, so then your 4 years would pass in this breadth slash depth development. And third is, I think you should learn how to communicate with people. So even with breadth and depth, you may be unsuccessful because you don't know how to communicate any of this to other people. So that is a very important skill. So you have to learn how to communicate. Now in this era of internet or ChatGPT or Gemini, you can ask Gemini and it will answer and give you a whole essay. But that still may leave you with bad communication, because when you are talking to somebody, they don't care about ChatGPT, they care about what you are saying. So what are you supposed to say? That's your communication skill. That still has to be developed.
So I think students should definitely write it down, because these skills are really, really important and they're very crucial as well. So moving on to next question, sir. Which areas do you believe will shape the future of AI and theoretical computer science in the next decade?
So I'm not really a technologist, although you would think that I am. So I can't really comment on this as you would hear in other podcasts on YouTube. So yeah, I would not comment on what exact area will grow. But let's say if we localize this only to India, then in India, theoretical computer science uh, has grown pretty well. And in fact, the initial departments which were created in India, departments of computer science, they were always they were always um, well, they started with theoretical computer scientists and they created more computer scientists who were doing some sort of theory. So I think India has good, it is safe to say that India has good theoretical computer scientists and they are graduating the next generation. So whatever they are interested in, those areas will keep growing in India. What will grow in India in AI, I think, is not may or may not be basic technologies in AI. They may grow, they may not grow, I don't know. But definitely the use of those for the Indian public will keep on exploding. Yeah, so how it is applied in the lives of Indians and the Indian government, that is unstoppable, and it will grow exponentially because this gives people jobs. I mean, these trained Indians, it gives them jobs, so they will keep creating those things for profit. So that is what will grow, continue to grow, and that is where, which is why again in the introduction I said that since some of the students here will create big companies related to this aspect of AI in India, how AI is to be used. So you have to be good in understanding that, okay, AI technology which probably was built in the US after spending billions of dollars of free money, uh, the same thing cannot be copied in India, because nobody is going to give you that kind of money to just buy lots of GPUs and then just train stupid models on the GPUs to solve something which for which anybody, anyways, you can hire an Indian. I mean, you want somebody to write an essay, there will be many Indians good in English who can do that job for you. So you don't need GPUs and train GPUs or over years and get all this. So, so yeah, when you transport the technology the way it was developed abroad to India, this itself is your startup. This has to be done in a new way, in a cheaper way, and it has to scale not for 100 million, but it has to scale for 1 billion, which is a huge factor. So, so you have to scale it up to 10 times in lower resources. So that is the future. How will it be done here? Correct.
I would like to ask another question on a lighter note. Outside mathematics and research, what hobbies or interests help you relax or stay creative?
Uh, the usual things, but one thing which is unusual is I like Western classical piano, so I play piano every day.
Oh, wow.
So that is something which very few people do. Other things are what others also do, which is travel or reading books, which is usually non-fiction, one or two fiction, but usually they are non-fiction. So then we have great facilities in IIT Kanpur. We have a Olympic-sized swimming pool. Now we actually have two. We also have a smaller swimming pool. So sports facilities are great. It's also good for walking and cycling inside the campus. The usual things, and then something which is special to me, which is the classical piano.
So, do you feel that being involved in the extracurriculars also contributes in your life, in having a successful life?
I mean, this is the, yeah, it's obvious, sure, because I mean, you will not be able to sustain your energy just in profession for a long time unless you have something else. This goes back to the question you had asked. The what do you do in the toughest moments?
Yes,
So,
sir.
so if you are in a interesting profession, then very frequently you will get stuck in big problems. So when you get stuck in big problems, how will you get unstuck? So for that, you just that profession isn't going to give you the idea. You have to have some other space as well.
Yes, sir. Absolutely. Ma'am.
So I guess we have one question.
Sir, good afternoon. I am Dr. Azharuddin. I am a non-technical person, but I got so much interest which you talked about theoretical computer science. So I want to know that we always talk about building real life solutions. Whatever students are learning, they have to use it and they have to build a real life solution. And you also gave a wonderful example of image sensing. So what I have understood that you guys interested in theoretical computer science would challenge the solutions of the applied computer science. Is it so? Are they complementing each other or are they contradicting each other? So I want to know from you.
Well, as all answers in philosophy, both. It's both yes and no. It's so the and these two opposites are connected because I mean, which I already said actually in various ways in the previous question answer that um, so in many problems, theoretical computer science will, or well, in all the problems and all the algorithms, what theory will tell you is that there is this algorithm which takes this much time. Now the time is, I mean, it may depend on the computer architecture and how powerful your machine is. So, but there is some way to define time in theoretical computer science. So we can make a statement that this algorithm is fast or this algorithm is slow. So that rigor is provided by theoretical computer science. But then when you give this very rigorous analysis, what you are missing is that maybe in practice, in like you said, real life solution or real life problem, maybe not all the parameters are important. Maybe only 10 parameters are important out of 1,000. So there is no way to know that in theoretical computer science because we are not um, taking into account what does the client or the consumer want. So the consumer part comes on the engineering side, that engineers know or they guess what the consumer or the client wants, needs, and then they can only focus on 10 parameters and they can solve the problem anyways. So so you can ask, okay, well, then what is the point of doing any analysis in theoretical computer science? So the point is very nuanced. The point is that this engineer also will know some theoretical computer science. The engineer will know some algorithms. The engineer will know what works on a computer. So that training the engineer has, like even when Google was built, and when ChatGPT was built, and now the other models which are being built. These are all mathematical exercises. So this is not being done by somebody who doesn't know uh, the math of computer science. In fact, they know it very well. So this is why it's both yes and no. So you have to see what is it that you are trying to solve. So within that framework, you can use either the difficulties which the theoretical computer science analysis will present, and then you can become an engineer and you can say that, okay, since it is so difficult, I'll do something simple. And in simple, you can find then methods, mathematical methods, algorithmic modeling methods. So the modeling is mostly a probability statistics exercise. So then you can try to do a stochastic analysis and on certain inputs. So the data sets are always very special. The data sets are not general. As I said, if your system is built to discriminate between man and woman, then it completely fails when you put an animal there, like a cow. So it gets completely confused because the model is not built for that, and then it gives random answers. So you have the data set has to be specialized. So I hope it answered your question because it's a philosophical stand. You cannot say that this is the correct answer.
Right. Any other question in the audience? Yes, we have one question.
Good afternoon, sir. So my general question, it's like a general question. I just wanted to ask, see, college students reach home late, around 6 or 7, and then we lack motivation to study. Even though we want to study, but we can't study. So we just sit there relaxing for like a half an hour. We think that we'll relax for 30 minutes, but then we start scrolling through Insta, Reels and all. And we don't realize how time passes, and then it's suddenly night around 9 or 10. And then we see, oh, it's late now, we need to sleep. Even though we don't sleep, we still keep scrolling. We like, there's no use of studying now. Our sleep schedule is messed up. So, like, how do you think we can avoid procrastination? Because I think we do lack motivation to study. Even though we have motivation, but then we don't put it into performance, or like we don't take action on it.
Procrastination. Well, procrastination has many, many reasons. Primary may be that you are not interested in that subject. A second may be that you think that this can be done, this will take a small amount of time, so it can be done tomorrow. And third is, as you correctly said, that you are just tired. So you have to identify the reasons, write down the reasons in a notebook, and then depending on what you think is the strongest reason, try a solution depending on the reason you think is, if there is. The other point is, I have to tell you a secret that which is that if you really want to focus on one thing, which is the depth part, right? So breadth is studying everything, depth is doing one thing. So the secret is, which your teachers and principals will not approve of, is that you have to steal your time. Then you have to stop doing things that you are not interested and steal that time to do something which you are interested. So if other things are making you exhausted, don't do it. You focus on things that you are interested in, so then you will have more time for it. So it's not necessary that you have to allocate your time equally to all the activities. You can bias towards your time towards the thing that you are interested in to reduce exhaustion, which is because you are spread too thin. So that's a secret. I mean, that if you steal time, then you will get bad grades or you will miss those classes. But that is between you and your college. Don't quote me on this. I mean, you can ask more questions.
Because the student always yes, please go ahead.
A very bright afternoon, sir. It's a privilege to me that I am asking a question from you. That do you think that AI can think like humans? Why or why not?
This is a even ChatGPT can answer this question.
Yeah, but I want the answer from you.
This is a even ChatGPT can answer this question. See, before the problem with these questions is that none of these words which you are using are defined. So you don't know what thinking like human means. We still don't know that. What does it mean, thinking like a human? In fact, what does even think mean? So these are not defined terms. So till you define them, uh, you will not be confirmed that AI has become a thinker, because you don't know what a thinker is, right? So that is the loophole in all these questions. But this maybe this will be too hard to accept. So I should give another answer. So another answer is that right now, whatever the models are doing, though the models are uh, this is not what human beings do. So that may be a simpler answer. So it is, everybody accepts that what the way the model works, that is not how the human brain works. So these two are different machines. So just by this, AI cannot become humans. It is not that technologists are trying to mimic the human evolution. So human evolution, it was different, and this mathematical evolution or the modeling evolution is totally different. So now where these two will converge will also be different. So it will just be a different type of thinking machine. I mean, I don't like the word thinking, but if you say thinking machine, so this will be a different kind of thinking machine than what the human evolution led to. They will not be the same.
Well, I hope that answered your question. Okay. So, with this, we'll wrap up the session, sir. Thank you so much for gracing today's session. I'm sure the students and the faculty members who are sitting here had ample of insights that were shared by you. Thank you once again, sir, for your valuable time and for your tireless contribution in the Indian science. So, before we wrap up, I would like to ask our Director Engineering, Allen House Institute of Technology, Professor Manoj Kumar Mishra, sir, to present the memento. Let's have a huge round of applause for
Thank you.
Professor Nitin Saxena, sir.